Today we're going to talk about a robustic public transit modeling approach, which may be developed that's from the GTFS data on the existing highway model, or maybe even on the normal model without the highway existing model as well, through integration of transit data with GTFS information. Our key contents are, each content can go like a presentation. This is like a vast subject. And this is not something that we adopted on any single project. This is the kind of methodology that we adopted on many projects into an existing highway model, or even on some BRT study, which we recently adopted. The first topic is like introduction of public transit modeling and GTFS information. We are basically focusing on the key challenges and key advantages on the GTFS data and understanding the existing highway model network and how for the integration and data preparation for the integration, what are the key challenges and key steps that are involved as part of the methodology. And finally, the integration of GTFS information on highway model, which is a key step in this process. And once we have all the model data into a combined model, the final refining and building as a robust, comprehensive transit model. And we gonna end with a comparison with the standard model approach as well as the GTFS information method. Yeah, this is about us. Myself, I am Sureshana. I am a lead travel demand modeler from East Central Advanced Mobility Group, led by Shankar. And we have a group of 20 people in that region. I'm accompanied by Marian, so she'll continue and then, yeah.
Yeah. Hi, everyone. I'm Marianne. I'm with the JCOT in the Houston office, but I find myself working a lot with Shankar's group in Virginia. So before we get into the nitty-gritties of this presentation, we want you to, first of all, understand that developing public transit from scratch is a very complex process and is time intensive. And in developing the process, it involves planning, it involves operations, it involves data integration as well. So putting all these elements together makes it very complex and also time sensitive. And there are so many challenges that comes with developing transit data. And we'll share a few. This is not subject to all, but we'll just share a few with you. One of them, the major one, is data collection. So getting quality data is very important for developing a transit model. And oftentimes, there's this issue with having a synchronization between the different data sources from the different agencies and authorities as well. And also sometimes the data is outdated, so it becomes a bit of a challenge. The other thing is also defining your transit network. So typically you have to define your transit network, which includes your stops, your route, and then your service area. And oftentimes there's a conflict between, coverage versus the coverage area versus the efficiency of the transit network. And another challenge that typically you would face is also the issue of the geospatial placement of stops. So typically stops should be strategically located, safely and easily accessible to all, but that is one of the challenges that likely to face with some of this data and integrating it into a public transit model. And that there's also the issue of the complexity in coding. So it's very difficult and complex coding different transport modes, ferries, bus, metro, rail. It is very complex in coding that. And the other challenge is also having obtaining and integrating timetable info. As I stated initially, having a synchronized schedule between some of the transit authorities and what is provided out there. And also there's this sometimes a conflict between the real world schedule and then the static schedule that you also have. So that is another issue of conflict as well. And then typically you also want to have a good transfer, which improves ridership and also being easily accessible. So these are some of the challenges that we face. The other thing is also the dwell time validation and then quality assurance. Quality assurance is very important because it ensures data equity and equality, because these data sometimes are coming from different data sources. So QA is very important to ensure data integrity. So in talking about this, Suresh highlighted that this as a methodology approach, it wasn't specifically used for one project, although we recently implemented it in a BRT project. But the GTFS data is an open source data, and it usually provides a standardized data, which includes transit routes, it includes stops, it includes schedules, and it's an open source data. It's free for all. It's accurate, and usually this data is often updated by the transit authorities. And it's also very, it can be used it's highly compatible with most modeling packages. So it makes it very ideal to use it to develop and build and maintain your transit data. Before we are able to integrate the transit data into the highway network, it's important to understand the basic structure of the highway network, which would typically include having your nodes, the links, the transport systems, the link types, and also would account for the capacity, the intersections, and then the transit only routes. So all these come together basically to form the backbone or the framework for developing the transit model.
Thank you, Maria. So as Marian mentioned, building a public transit model from scratch is always challenging, and it's extensive work. And then, so even like in terms of time and efforts, it's always like challenge. So the following slides will basically tell us how exactly the integration methods and what are the data preparation and integration methods that we adopted. As a first step, I mean, we should thank PTVB Zoom because we have a single tool where we can directly import GTFS information into Vizum. So it's like very simple single click on that. And that's the first step. And then the existing highway model. So if you want the GTFS information that we have to import, so we need the GTFS information for the area. It's always with our experience, what we noticed is GTFS information is like wide area. It's not like the specific study area that you always look at it. So we need our particular territory to extract the actual area. So to do that, if you know the highway model that you have the specific study area, so you can always like define a territory where you're gonna cut the sub area, and then eventually which you're gonna develop the public transit model. And to do that, you have to create a territory in the highway model, and you have to export that as a shapefile. And then, I mean, before that, you have to import the GTFS information and to make a Visum transit model, which will basically give you all the transit information like Marin mentioned. So the key information that which we don't get from the authorities is like travel time information, which is like travel times of the different routes and different services. That's very tricky, and especially those are like parallel services that operates on the same one, and even the stops are sometimes they may skip. Sometimes it may be like single integrated station that we have. And the next step, like, so once we have the big model and using the territory, we can always like generate the sub area. I don't know whether my mouse is moving, but like the image on the top is like the wider area, which and the dot that we have kind of imported is like very small study area, which had like everything all in together. As part of the integration, the GTFS information, then the key next step is like once you have the network in it, so you have to save it as a .NET file to bring into the existing highway model. And also the key thing is like the transportation systems in highway, we don't often have all the transit modes in the model, we have to ensure like we have all the transit models in the model that you are going to incorporate or integrate. And also the spatial referencing is the challenging because we are bringing like two different model sets. We should make sure like the spatial referencing is correct. And once we have set everything, this is the key and critical process where the highway nodes and the PT transit stops are integrating. So we should set a offset to bring into this model. Let's say we have a transit stop and the highway node in the model. So if you want to combine into that, you should set the offset of radial and then bring it to the model. Once you bring into the highway model, and it'll be aggregated to the transit stops with a snap radius, like I mentioned. And I mean, once into the transit highway model, and we have to make sure all the parameters with the different modes are set, because each public transit route will have like different mode, will have a different parameter sets. And finally, I mean, when we have this step is ready, so we have the integrated network model is ready, but that is like very unrefined model that we haven't. And what we get from this is like we have all the transit data integrated into the highway model with whatever the transit stops that we have. But it's not really exactly aligned to the network in terms of the routing. That's a critical step. Next. Yeah, and this will be like network review and calibration part as the next step. You have to read out as you see in the image on the left. So you can see like that's only integrated on the key stops, not everywhere along the route. So we have to read out. So and I mean we have to calibrate to the travel times. Those are the critical challenges and resolve all the inconsistencies. And also, I mean, especially if it is a multi-model integration model, so we have to make sure like all the models are integrated and the transfers are making place in correct. And also perform, I mean, do you have to run at the end? I mean, once you do and bring in and do the corrections and do the calibration, you have to make sure the metrics are performing well. So that's the end of it. Yeah, we coming to the comparison and conclusions. So if you are doing a standard public transit model from scratch, and you need like extensive data from authorities, which is always a challenging. And here the GTFS feeds it's very easy, especially in Visum, you can directly import in a click way, which is very accurate and always often updated by authorities, which saves you like you saves your time, cost, and effort. And developing it from scratch is always challenging. You have to place stops and networks and travel time, which is very challenging. And in terms of the complexity, it's very high, and GTFS is very easy. And in terms of the standard modeling as well, as we need like from junior level start to all the way to the senior level to QC, require some expertise. And finally, to the cost and the efforts with our experience where we have adopted. And I can say the standard approach took around 2 months. With this approach, it took just 2 weeks. That's the amount of savings and time and cost that we witnessed. That comes to a conclusion. Thanks, everyone. Thank you.